Hi, welcome to Bald Spot Math. By now, you should know how to find the area of various polygons. Triangles, rectangles, squares, parallelograms, and a couple others. Today, we're going to talk about finding the area of other polygons, including regular polygons. So let's get started. Alright, first of all, quick vocab check. What is a polygon? It is a closed figure made up of at least 3 line segments. So a triangle is the first polygon because it has 3 closed line segments. Here's some examples, and of course there are more than this. Here's some basic examples of some polygons. And as you can see, they're not necessarily all shapes that you're familiar with. So what are we going to do to find the area of some of these polygons? Let's take a look first at a trapezoid. Some trapezoids you can decompose, you can break them apart like we did with parallelograms and kind of put them together in different ways. Or we can break them into shapes that we're more familiar with, find the area of each of those shapes, add them together. Let's take a look. So, I've got a trapezoid here, and there's a couple of things that I can do. So, I can break it into some different shapes. I'm going to use that color. Alright, I am essentially making 3 shapes here. I've got a triangle, another triangle, and a rectangle in the middle. I know how to find the area of each of these shapes. So once I do that, I find the area of all 3 of these shapes, I add them together, and I have the area of my trapezoid. Now, as with many things, there's a formula for this as well. Let's take a look at how we get that formula, and then we're going to use that formula. Okay. So, we have another trapezoid. This is a trapezoid again. It looks a little bit different than the other one. It's going to help us figure out how this formula works. So what I'm going to do first is I need to copy that shape. And then I need to paste that shape. And there it is. Okay, so now I've got 2 of these trapezoids. Bear with me here while I rotate that. Now, hold on. A little bit more. My board gets a little temperamental. There. I'm going to take my second trapezoid, which is the same exact size as this first trapezoid, and alright. And of course now I've got a rectangle. And if I take and label this, what do I have? Base 1 is down here. Base 2 is here, and of course this is the height. And what do we know about the area of a rectangle? The area of a rectangle, of course, is base times height, right? Well, in this case, what is the base? The base is base 1 plus base 2. For this whole rectangle, it's base 1 plus base 2, and then I've got my height. So if I wanted to find the area of this rectangle that I've constructed, it would be area equals base times height. But base, remember, in this case, is base 1 plus base 2 times height. But what does that tell me? It tells me this whole thing. But I only want half. I only want to know the original trapezoid. Alright? And that's why if I take this, which gives me the area for the whole rectangle, and cut it in half, what do I have? I've got my trapezoid formula, which is why you see here we're multiplying by half. So what's the formula for the trapezoid? 1/2 times the sum of base 1 plus base 2 times height. And there you have the area of a trapezoid. Plug in your numbers, solve, you're good to go. Alright, so we just finished finding trapezoids. What about other shapes? And we're not going to go, of course, through every shape, but a lot of what you've already learned works for these shapes. Again, break them down into shapes that you understand, add those different areas together, or use some of these formulas. Let's take a look at regular polygons. Quick vocab check. What's a regular polygon? They're polygons with all sides and angles that are equal. That's what regular means. So we're going to use decomposition to find the area of a regular hexagon. And of course you can do this for lots of shapes. So here is a regular hexagon. As you can see, all of the lengths of each side, and if you were to use a protractor to measure the angles, you'd see that all the angles are equal as well, and that's the definition of a regular polygon. What can I break this into? I can break them into congruent triangles, equal triangles. Every single one of these triangles is exactly the same size, and of course, we know how to find the area of a triangle. It's 1/2 base times height. So once I know the measurement of one of the bases, once I know the height of one of the triangles, I know it for all of the triangles. And I'm given my measurements here. I have to have my formula. Oh, here it is. Now I've got not just 1/2 base times height, I'm multiplying it by 6. And why is that? Because it's a regular hexagon and there are 6 triangles. So it's 6 times 1/2 base times height. I plug in all my numbers, I get 41 52 inches squared. And you can use this for lots of shapes. Now you can't always break all of the shapes down to triangles, but the decomposition into familiar shapes and finding those areas and putting them all together will work. And that's it for today.